Hi, my name is Robert Ebelher, and today I'm going to be talking to you about applying cognitive engineering to the design of a symbiotic counseling support system. So, a brief overview of what I'm going to be talking about today. We're going to get into how do you really create an effective counseling system, the symbiotic approach, some issues when addressing the implementation of a computerized counseling support system, some reasons for project failures and some project success factors, um, some ways to gather information and user needs identification for this system, requirement specifications and screen specifications, and then a summary. So how do you create an effective counseling system? So really, you need to be able to translate usability requirements into specifications, and this is basically when you gather, user requirements, from the actual clinical staff. How do you translate that into actual, system specifications? And then also you have to have an understanding of the working practices and cognitions of the staff, which kind of plays into that first bullet there. You have to be able to integrate psychological theories and practices with computer engineering, which basically is called cognitive engineering. So all these kind of play together to create an effective counseling system. So the symbiotic approach. So this basically suggests, potential biases, limitations, and cognitive abilities. And what this basically means is, when you have a human entering data into a system, that the human can be potentially biased for the inputs, and the computer has to be able to kind of aid in that, in that sense. Studies whether production derived from a cognitive model applied to a task. Psychological methodologies can contribute to design, and this is basically plays back into what I said before, where you have to take into consideration all these how the clinical staff works when actually implementing a design with those the user requirements, the usability stuff, collection and displaying of data in a uniform way, decision support system to aid in assessment into interpretation, symbiosis between psychological and human factors, computerized decision support system. So basically what most of this is saying is you want a system that can aid with the clinical staff and help them when they're inputting data to the system, and it's not biased. So wherever the computer can aid in that, we have to, as engineers, have to be able to handle that. Okay. So here's a little graph on the symbiotic approach, and as you can see, that top box there is the clinical practice, and at the very bottom you can see you have the IT, information technologies, which has the engineers in them, and how both of these combine to create the human computer symbiosis, as you can see in the middle there. You have the user needs and the computer engineering capabilities coming from the clinical practice, and then the office systems models and the computer tools coming from the IT side of things. And then on the bottom right, you can see the design principles and methods to be used, which interact between both these fields of work. So some issues to be addressed when implementing a computerized counseling support system. So with this, you need, the first thing is you got to have engineers to be able to maintain the system, whether they're currently on the staff or they're in-house. There's always going to be updating and maintenance for this system. And then there's a huge place for legal. You have to make sure that the system's reliable and secure, so that data doesn't get leaked. Data isn't easily obtainable through hackers getting into the system. So those are pretty big issues there. Also, all the employees that will be using the system have to be trained, which takes money and time to do. So these are all things that you have to play into the implementation of the system. And then, like I said before, the human input into the system, there's a lot of human biases that can happen. So we have to be able to handle that. The system and the engineers, we all have to be able to work together to make the best judgment calls on that. So it's here as a little graph on reasons, the top reasons for project failures. Incomplete requirements, lack of user involvement, lack of resources, unrealistic expectations, lack of executive support, changing requirements or specifications, lack of planning, and didn't need the system any longer. And as you can see, the top, this is rated from the top percentage to the lowest, and you can see, incomplete requirements is at the top, and that's a huge part in this, because we really want to nail down those initial set of requirements, those usability requirements, which will play in the future when we create the actual specifications for them, and which can help limit the amount of defects within our design. This is another graph, which is actually the project success factors. Again, rated highest to lowest percentage. User involvement, management support, clear statement of requirements, good planning, realistic expectations, smaller milestones, competent staff, and ownership. And as you can see here, again, user involvement is played in here. And this, the way I see this is, the user involvement basically, would be the clinical staff, the people that are actually be using the system, how they play such an important role in the project success, because in this aspect, the users, the clinical staff are the ones using the system, so they're really going to have to tell us what they want, and we're going to have to, as engineers, be able to make the decisions to aid them and kind of reduce the human bias for the inputs they'll be putting into the actual system. So that's where we come into play. So we really have to work together to make a solid project here. So information gathering and user needs identification. So observation. So first, basically, as engineers, to work together with the clinical staff, we have to be able to observe them, so we can collect data ourselves alongside of their inputs to us of what they actually need. So basically, we want to be able to observe them in their working environments. We want to do this in minimum of 2-week intervals. We want to do this at different times of the day and different times of the year as well. So we have a large variety there, so we can take all the data we collect there and kind of develop a great system with all that data, make better judgment calls there. We also want to be able to review all the paperwork that are used by the clinical staff. Basically, all the notes the staff will be using to for their clients. We want to be able to see what documents are actually need to be maybe locked down more, so that maybe there's some visibility rules that need to be done to make sure that only certain people see these documents. So that's kind of where the reviewing of the paperwork plays in part there. We also want to have discussions with every single clinician on staff, basically, so we can see and kind of create a list of items that maybe they want, or kind of how they see the system being and such. So, and then make judgment calls on that. We also want to work through a couple mock cases from start to finish of how these clinicians actually work, and how they would actually put their work into a system, or how they currently do it now, and how we can improve that. With what also plays in that is we want to also review the current system that's in place, kind of see maybe the aspects that they like about the current system, maybe the things they don't like, and kind of use that to build into this new system. And then when this new system's in place, we want to, repeat all these steps. Maybe, we wouldn't observe the staff again, but we would, want to, see how the users actually use this system properly, and how, if they like it so far, if there's changes that need to be done, kind of get some feedback on that. So the requirement specifications. So basically we want to be able to, review the user requirements between the engineers and the clinical staff, so we could actually create these, specifications. And once that's done, then the design of the system will begin. And basically, so here's, a basic, initial screen, what it would look like when the web page loads up for these, or, maybe it's not a web page, but more of a desktop app that these, clinical staff would use. And basically it's some pages of main screens on this page would be, to do, scheduling, patients, staff, and library. And I'll go into more details on this next page here, but that would be the initial screen that, a user would actually see. So as you can see from this diagram here, you have your main pages up top, and you can see how they kind of interact with these, kind of sub pages here. You see like a library, which allows you to get to forms. If you go to the patient's page, you can see the patient's histories, the patient's assessments, the treatment plans, the notes on the patient, and you can see how these different things interact with each other. Like the treatment plan can be seen from the to-do page and such. So this is just a kind of little graph there to help aid in the design phase. So here's another design page, but this has to do with like screen specifications. So all the fields listed will have a drop-down choice to save clinicians even more time during their input of the different fields. So I'm not going to go into details. I'm not going to read every single one of these out, but basically these are going to be fields or maybe different pages that the clinician can go to and maybe input data on. And some of these fields may require the computer to aid and to help aid in the bias, like I said before, the human input biases. So this is where this is where the engineers come into play to kind of help that aspect. So, we talked a lot today about, the role of the cognitive engineering. Like I said, I talked about, how important it was for the user of the system and the engineers to actually, work together to create these. First, they create the usability requirements, and then to be able to also turn those usability requirements into actual specifications. And when it's not easy for the IT and, a field like psychology, to come together and create a system together, and to create a system that is, usable. And you've got to be able to interact and use, be able to research, the psychology aspect of it to be able to create this system. So there's a large part on the initial requirements gathering, and this is where all these, psychological aspects come into play alongside of the requirements gathering. We also talked about the symbiotic approach, went into details there, showed you a little graph of all that stuff. Like I said before, the fields of IT and psychology play in the requirements aspect of things. And also, how, what things were aided in the design process of everything, and the psychological theories and the clinical user requirements, how those were, aided in the design process. But that's all I have for today. Thank you.